All right, I want to take a look at the algebra related to some of the graphs we just saw. We looked at r equals sine theta and said that that looked like it was a circle here that got up as high as 1 on the y-axis. Is it really? It turns out it is, and I can show that by converting this into x's and y's. And I'm going to do that by multiplying both sides by r. This is r squared is r sine theta. Now it looks like I squared the left hand side. I didn't. I multiplied it by r and I multiplied the right hand side by r. Okay? And the reason I'm doing this is because by multiplying both sides by r, I've made both sides look nice in regards to things that I know how to convert. So r squared is x squared plus y squared. Likewise, r sine theta is y. So I've got now an equation that looks like it's in x's and y's. Okay, is that a circle? Well, it's not a circle centered at the origin, because that would be x squared plus y squared equals a constant, and this isn't a constant, this is a y there. But I can figure out where the center is. Well, first of all, I know it's a conic section anyway, because it's just quadratic in x's and y's, and I remember my pre-calc 1 days of doing conic sections. They were all quadratic in x and y, so maybe it's an hyperbola or an ellipse or something, but it turns out it's a circle. I'm going to subtract the y over to the other side, and then I'm going to do a complete the square on the y's. X squared plus y squared minus y. So I'm looking at the minus 1 coefficient here, cut it in half to be minus a half, and so I'm going to take that and square it. So I've got minus a half squared, and I'm going to add that to both sides. Well, the fact that it's minus a half really doesn't matter, because I squared it's going to be plus. So I've got x squared plus y squared minus y plus a fourth. So I added a fourth onto both sides. But the thing is, this is a perfect square. This is x squared plus, this is y minus a half squared, and this is 1/4. Now this looks like a circle. I've got an x squared plus something squared equals, this is a y minus k. So this is a circle that's been shifted 1/2 in the x direction, and the radius is the square root of 1/4. So this is a half squared. So this is a circle, radius a half, centered a half up the y-axis. And whoops, well, my iPad is dead, so I'm using a pen and paper here, and I can't erase that. But this is, so maybe a half is right there in the middle, right? There's your sine. Likewise, if I did this with cosine, r equals cosine theta, we saw that looked like a circle over here. It started out at 1, came down to 0, and then went out like that, right? Well, I can do a similar thing here, multiply both sides by r, so I've got r squared equals r cos theta. Again, the r squared is x squared plus y squared, but now r cos theta isn't y, r cos theta is x. And when I bring that over, I'm going to do a complete the square on the x. So again, you take the 1, cut it in half to get a half, square that, that's 1/4. So I'm going to add a 1/4 on to both sides, and I've got x plus a half squared plus y squared equals, wait a minute, what happened? I subtracted it over there. This is a minus, this is a minus, this is a minus. It's still a plus when I added the 1/4 on, because I took the half and squared it, so I should have minus a half squared. So let's write this a little nicer. This is x minus a half squared plus y squared equals a half. And sure enough, this is the circle as we have it stated here. The center is a half over in the x direction, no shift in the y direction, and the radius is a half. So it comes back and passes right through the origin. Okay. That's those two. There were two others that were of some interest to us. Secant and cosecant had some interesting graphs, right? When we looked at the graph of y equals secant theta, it looked like it was just x equals 1, right? It looked like it was just a straight vertical line there out at 1. Well, it turns out it is that. sorry, not y equals, come on now, how many mistakes can I make here? This is r equals secant theta, right? It looked like the line, this is x and y, it looked like x equals 1. Well, the thing is, secant of theta is 1 over the cosine of theta. And if I multiply both sides by cosine theta, I've got r cosine theta equals 1. But r cosine theta, I can convert that into x's and y's. R cosine theta is x. So this is just x equals 1. This equation, r equals secant theta, turns into that equation, x equals 1, when you convert it to x's and y's. Likewise, if you look at r equals cosecant theta, well, cosecant is the reciprocal of the sine, and multiply both sides by sine, it looks like that, and r sine theta is equal to y. So y equals 1. So sure enough, those graphs that looked like, this is the x-axis, that's the y-axis, they looked like they were straight lines, are indeed straight lines. One more. I was just looking at how much time has passed. One more. We looked at the tangent and the cotangent as well. I want to look at the tangent and see that this is a really goofy thing when you turn it into x's and y's. But we can turn it into x's and y's. So I can grab another piece of paper here. There we go. Here's another piece of paper. R equal tangent theta. The graph looked something like this. It seemed to have maybe vertical asymptotes here at 1 and minus 1. Can we convert that into x's and y's? Well, actually, it converts fairly easily because tangent theta is y over x. Right? So I've got r equals y over x. If I square both sides, r squared equals y squared over x squared. And I squared both sides just so that I could use, so I'd avoid the square root, right? R squared is x squared plus y squared. So x squared plus y squared equals y squared divided by x squared. Now I tell you, I don't think there's any way that if you said, hey Will, draw the graph of that thing. It's like, what? I don't know that I can. Or if you even multiply it out, so you got x to the fourth plus x squared y squared equals y squared, and then subtract anyway. X to the fourth plus x squared y squared minus y squared equals 0. I mean, any one of these equations is an equation that describes this thing in x's and y's. I kind of like this one. It's a little easier to deal with, right? This is one of the reasons why we have another coordinate system. In fact, there's more than just rectangular and polar. You can think of other coordinate systems as well. And each one has ways of describing curves more simply than others. This curve is fairly complicated to describe in terms of x's and y's, but it's fairly simple to describe in terms of r's and thetas. Anyway, you could do a similar thing with cotangent, but I think I'll leave that to you.